All right, so anybody who's been in my cognition class, this is going to sound really familiar because we talk about attention and cognition. It's a pretty pervasive feature of sensation and perception. So question is, well, first the question is, what is attention? And William James answers that for us very nicely. That you already know what attention is, right? So James says, everyone knows what attention is. So since you already know this, and we know it to be true because William James says so, what is attention? So maybe Hal Pachler is right, where he says, no one knows what attention is. But he's questioning James. We can't do that. It's gospel. So what do we mean when we talk about attention?
I'd say it has to do with your ability to stay aware of stimuli.
Okay.
You're coordinating stimuli.
So isn't that just the same thing, though, to be aware of something and to attend to it?
So I'd say the difference is where you focus. You can be aware of a lot of different things while around you, but you're only focusing on one thing.
Okay. So I'm
So
aware.
that's where your attention is.
Okay. So I'm aware of everybody in the class, but my attention is drawn to the rustling of the newspaper. Right? So that's what I'm attending to. But, okay, so maybe it has to do with where your focus is. Any other definitions of attention?
I'd say that some people know what attention is.
Some people know. So attention experts know what attention is.
Yeah.
Just like people who know what an onomatopoeia is. Linguistic experts know.
It's just not everyone or no one. It's just some people.
Okay, so if you've taken a class in cognitive psychology or sensation and perception, you know what attention is. All right, so we're going to start off talking about what attention is, and it's sort of defined by its limitations. And then we're going to talk about those limitations and how we get around those limitations. So how do we allocate our attention? Because attention is limited. So it needs to be allocated to certain areas of space, certain stimuli. How do we do that? How do we protect attention? We'll talk about spatial selection and then visual search. And we're not going to get through all of this stuff today. This is sort of the roadmap for the rest of the week. All right, so attention. So I think I got this out of your textbook. So attention is any of the very large set of selective processes in the brain, which is a really broad definition. It's sort of like not any more helpful than William James, right? Everybody knows what it is. It's a broad set of stuff that's going on in the brain. So it turns out that you've got how many neurons? 10 to the 10th neurons, something like that, with 10 to the 11th connections between them. So you've got as many neurons in your head as there are stars in the Milky Way galaxy. Huge astronomical numbers of cells in your head. All of which are doing these computations, all of which are involved in cognition. In spite of this, in spite of these huge numbers, and in spite of their amazing abilities to do parallel processing and all of this stuff, you still don't have enough resources to process everything in your environment. For example, when we talked about color vision, remember that you've got good color vision for, for the phobia, basically, right? So an area about this big at fixation. So you can do color processing on that much information, visual information coming in, but you can't do color processing on everything. So what attention does is it sort of takes these limited resources and it allows you to focus your processing on limited stimuli in the environment. So the basic idea is that you have to deal with the impossibility of handling all inputs at once. And so you've sort of set up, or the nervous system has set up gatekeepers that sort of figure out, okay, what do we need to pay attention to now? Where do we need to focus our attention? I'm trying to think of a way to say this without using the word attention. Let me try it again. Where do we need to focus our processing? What stimuli do we need to process in order to be maximally effective? How about that? I don't think I used attention in that definition. All right, so the idea is that you restrict processing to a subset of things, places, ideas, or moments in time. So this brings up an interesting idea about external versus internal attention. Can you focus your attention internally?
Yes.
Yes, okay. So examples.
No. Well, like you can focus on your thoughts.
Okay.
You know, you can get things so that you don't hear it when people talk to you and stuff like that.
All right.
I don't know if this is right, but it seems like every time you zone out and you're like real focused on, I guess the same thing.
On your thoughts, right? So you're not. So anytime you see somebody sort of spacing out, just staring off into space, you know, where is their attention? Are they actually attending to what they're looking at? No, they're not really looking at anything in that case. They're attending to what's going on internally. So yeah, so you can focus your attention not necessarily just on external stimuli, but also on more sort of top-down stimuli, right? So more on your internal states, your internal thoughts. So selective attention is the form of attention involved when processing is restricted to a subset of possible stimuli. So we're mostly going to talk about external attention. So we're not really going to talk about focusing your attention internally. We're going to talk about, we're going to attend to or focus on selective attention and selecting out various stimuli. So there are different flavors of attention. And this is part of the problem for defining attention, because you can come up with any of these different definitions and they'd all be fine. So external versus internal, which we've already talked about. Overt versus covert. So overt attention is when you look at somebody. So if you're having a conversation with someone, you kind of want to direct your overt attention to that person, right? So look them in the eye, engage with that person. Although under those circumstances, you may also want to covertly direct your attention someplace else. So do I have the picture? I don't have the picture in here. Or do I? Let me look ahead and say no. Do I? No. Okay. So occasionally, well, maybe I'll let you guys come up with an example. When is an example of some time where you might covertly direct your attention someplace that you're not actually fixating? See that?
Every time you want to eavesdrop.
Okay.
Stare at something. Is this the right example? You stare at something, but really you're like trying.
Right, you're focusing your attention to the conversation that's going on beside you, but you don't want to look like you're focusing your attention on the conversation that's going on beside you, and so you look someplace else and you fixate over here, right? Yeah, great example. Others?
When you walk past your ex on campus, will you pull out your cell phone?
Right, yeah. So you've seen her, she knows that you've seen her, or she may not know that you've seen her, so you're trying to be tricky, and so you're doing this, but you're seeing who she's with, what she's doing, right? Yeah, absolutely. And
Texting
yeah.
in class.
So yes, I'm not texting right now. I'm attending to what you're doing, Dr. Gerwin. Yes, great example. The example that I always use is, say you're at dinner, you're having a conversation with someone at a restaurant, but in the bar they've got a TV going and the game is on. And so if you do this and stare at the game, then you know you're going to get slapped. And so you look like you're attending to what she's saying, but really you're trying to figure out what is the score of the game, right? So is my team winning or not? So yeah, so you can covertly direct your attention to places that you're not specifically looking, or that it doesn't look like you're looking at. We can talk about divided attention, where you try and do this texting and paying attention at the same time, or driving and carrying on a conversation, or driving and texting, or driving and listening to the radio, or driving and eating, or driving and what are some of the other things we do while we're driving? Shaving, applying makeup, etc., etc. That's kind of obnoxious. Yeah, so are we good at this? At dividing our attention? We think we are, but we sort of lack that insight that we are terrible at this, unless you're a super tasker. So it turns out that about 1% of the population is super taskers. 1 to 3% of the population. We're not entirely sure. These are people who can do 2 tasks at once, and they don't have a hit to either task. So usually, if you're trying to do 2 things at once, so say you got some visual task where you're trying to pay attention to a stimulus, and some auditory task where you're also trying to pay attention to that stimulus. Usually, what's going to happen in that case? one or the other, or more commonly, both of them take a hit. Both of them go down. These supertaskers, though, can do both, and they maintain their performance at both of them. And they're exceedingly rare. So there's a research group up at the U who are actually recruiting these people and trying to find them. And so they have people come into the lab, do this dual task kind of paradigm, and most everybody takes a hit, but about 1 to 2 people in 100 don't. So you can imagine the ends in these studies. Yeah. So they have to bring hundreds of people into the lab just to get a decent size group to do research on. And then they study these people like crazy. They stick them in the MRI scanner, they do gene sequencing, they do all sorts of stuff with these people just to try and figure out what's going on with these people. Turns out that they're equally distributed among men and women. So men aren't any worse at this than women are, as the sort of old trope goes. So it turns out that there's not really any evidence that men or women are better at divided attention. We're all terrible at it. So the take-home message from that is, don't talk on your cell phone while you're driving. Don't text while you're driving. Is that illegal here yet? Texting while driving? Texting is, talking is not yet. Does a hands-free cell phone help?
No.
No, it turns out it doesn't. There was a time when I was living in California where they outlawed handheld cell phones, but texting was still legal. So you could text, you could have your cell phone in your hand texting, but you couldn't hold it up to your ear to talk. It was the most bizarre thing in the world. About 6 months later, they outlawed texting as well, so you couldn't do either. But you can still have a hands-free cell phone, and it turns out that doesn't matter at all. It's not what you're doing with your hands, it's what you're doing with your brain that matters. All right, so that's a complete tangent, sorry. And then we can talk about sustained attention, which is continually monitoring for some stimulus, and that's sort of what we typically mean by attention, is sustained attention. All right, so if you were to do a task where I have you fixating on the X's, so keep your eyes on the X's. You've already read all this, I'm sorry. I should have warned you before. So, I don't know, you can make up your own stimulus and then show it to somebody and see if they can do this. So if you fixate on the X's, the letters are still big on either side. You can still see the letters and discriminate them. But if you keep your eyes on the X's and move down the page, you can't read both sentences at the same time. You have to pick either one or the other. So if you fixate on the X's and focus your attention to the left, you can read that sentence, or you could read the sentence on the right, but you can't read both sentences at the same time. So give it a try, even though you know what the sentence is saying.
Could a supertasker do it?
Supertaskers, I don't think, can do this. So I think that they can split their attention between different modalities, but within the same modality, within vision, I don't think that they can split their attention like that. Split brain patients could do this task, it turns out. So the left hemisphere and the right hemisphere can split their attention to different locations in space. So
they would only be aware of reading one side, though, right?
Correct. So if you asked them,
they would write the other one, right?
yes, exactly. Yeah. So if you asked them, so does everybody know what a split brain patient is? Yeah. So their corpus callosum has been severed. So this is a treatment for epilepsy. We do some really bizarre things for epileptic patients. So, and it's only as a last resort. So we try all the medications, they never work, and people are still having seizures. So you do things like cut their corpus callosum, or take out half of their hippocampus, or things like that. So if you have your corpus callosum split, it turns out that you can have dual foci, 2 different places where you're focusing your attention. And so a split brain patient could get both of these sentences, read them both. But if you ask them, what did the sentence say, what are they going to report? Is it time for a snack yet? So they're going to report what was on the right side. Why is that? Language is left lateralized. Yeah. So the left hemisphere is going to get what's on the right half of space, right? So we've talked about that in here. And so it's going to linguistically process what's going on the right. That when you ask them to verbally report, the left hemisphere is going to verbally report what it saw on the right half of space.
So the optic chiasm is in front of the corpus callosum. It's not part of the corpus callosum.
Right, yeah. So optic chiasm is separate, and it is intact in these patients.
Okay. So if the optic chiasm was cut down the middle,
what would they get?
like half of one side, I don't know.
Right, so if you were to sever the optic chiasm, ooh, this is going back a little bit, isn't it? What is going to result? All right, so you've got your two eyeballs.
You only get half the space.
So optic nerve, optic tract, optic chiasm. So the question is, if you split the optic chiasm, what's going to happen?
Left, right?
Did you only see the outside?
You would see, so let's see, if we've got some stimulus up here. This is going to be represented upside down and backwards here, right?
So you only get a quarter of space.
So you're going to get, in this eye, you're going to get this half of the information, right? Because this is going to maintain ipsilateral. And in this eye, you've got upside down and backwards. So you're going to get this half of space to maintain ipsilateral. So are you going to miss anything?
No, but
No, but would you lose all your binocular clues?
but your corpus callosum split too.
Yes, your corpus callosum is split. So the right hemisphere is going to get the left half of space still from the right eye. And the left hemisphere is going to get the right half of space from the left eye,
But it can't transfer over.
but it can't transfer over.
So you would only get the right half.
So you would only get the right half or the left half, and no transfer between them. So you could, in theory, do some visual discrimination task, train some information to the right hemisphere by presenting it in the left half of space, and that information is not going to get over to the right hemisphere. So you are going to lose some amount of visual information. You are going to have a scotoma. So the scotoma that you're going to have is going to be for overlapping stuff, is that right? So it's going to be the nasal hemifields. So you're actually going to have tunnel vision, right? So you're going to lose the stuff that's on the periphery, because that stuff is going to cross over and be represented in the middle in the nasal hemifields. So you will have some vision loss, but you won't lose any information. That information is still going to be present in their respective hemispheres.
Sorry.
Complete tangent, but you could see me not putting the brakes on that at all. So I'm okay with it. Mostly because we get to review sort of visual system anatomy and go back, because that stuff's going to come up again. All right, so yeah.
Well, I'm jumping ahead before you even talk about the slide. 'Cause I read it. So is it bad then to listen to music while you're studying?
Ooh, this is a good question. Is it bad to listen to music while you're studying?
And I'm asking like classical music, because you always hear that less bad.
Okay, so Mozart. Is it bad to listen to Mozart or Bach while you're studying? Stephen Covey would say no, that Bach is good. I don't remember his reasoning for that. There's some reason for that.
When I listen to music while I'm studying, my attention is not really directed towards music. It's just kind of there.
Okay,
It's like I know he's behind me, but I'm not paying attention.
okay.
I study best when it's like not obnoxiously loud, but when there's like people and crowds, like when there's just background noise that I can isolate. I can't study in silence; it drives me nuts.
Okay.
I'm actually the opposite. If I've got like any type of music going, I'll usually pay attention to the music instead of trying to read or study.
Okay.
For me, the way it works is if I have music playing, that way, if my attention wanders from the homework, it wanders back to the music, and then I remember, oh yeah, I'm supposed to be studying, so that it goes back to the study. And that's how music helps me study.
All right, anyone else? So how many of you do listen to music while you're studying? How many of you don't? How many of you can't listen to music? So we're pretty evenly split. How many of you don't study? I don't want to know. That information I don't want to know. So, no, to answer your question, it's not necessarily bad to listen to music while you're studying. For some people, for me in particular, so I know from my experience that I like to listen to music while I'm studying because it gives me something to tune out and it helps me to focus my attention on what I'm actually doing. So if I'm in my office and I don't have my music on, I can hear what's going on next door in the next office because it's kind of loud. And I can hear what's going on at the elevator and out in the hallway and students coming by and stuff like that. So that sort of stuff draws my attention. So that sort of messes up my allocation, right? So if I have music, though, I sort of drown that out. And if it's something like classical music, then that makes it easy because there's no words to pay attention to. I'm typically not engaged in the melody or anything like that. I'm typically able to sort of tune that out and focus on what I'm doing. If it's new music, if it's rap or something like that, where it's got words to it, and I don't listen to rap, and so rap is novel to me. So I'm more engaged in that. I think, oh, this is interesting. What are they saying? Oh, I don't want to listen to this anymore. So I'm going to switch over to something else. So yeah, so it helps if it's sort of background noise for me. So crowds also easy for me to study in because I can sort of tune all that out and give me sort of something to focus on. But that's just me. Other people, if you've got music, then you're going to attend to the music. That's something salient to you, and so it messes up your allocation.
Why would it be easier to, like you said, like if there's one person out at the elevator, that's distracting, but if you're in the middle of a crowd with lots of people making a little... Because I can't study in the library because everybody's trying to be quiet. There's always that one person, like 2 tables over, it's talking just a little bit too loud.
Uh-huh.
I'll sit there and just kind of look at them and half listen to their conversation because they're making noise.
Hang on to that question. Let me know if you still have that question after we go through the next couple of slides.
I was just gonna say it's like the when your sensation, when it's stuff that you get accustomed to. I have a roommate who cooks really smelly food, and so I don't even care. People come to my house and your house smells terrible. I'm like, I don't even notice it.
Right, exactly. So how do we figure out what to allocate our attention to, right? So we'll come back to that as well. To this question of change and do you get used to it after a while? So think about how your house smells. It probably doesn't smell. But if you go on vacation for 2 weeks and then come back, then your house definitely does have a smell, right? So how do you get used to that sort of information? All right, so the question is, what strategies do we employ to avoid distraction? I listen to music. Other people do other things. So I'm going to give you an example of a strategy. So everybody pair up for a demonstration. So pick who your partner is. You probably want to be close to your partner. So if you need to move, get up and move. All right, and figure out, I'm going to put the instructions up on the screen. So one of you figure out who in your pair is going to look at the screen, the other person look away. Okay, everybody ready? Here are your instructions. Got it? Okay, go. If you've done it before, you may mess up. No, that's it. So, just the one question. All right, so did this hold true in your case? So when the non-looker answered the question, what did they do? Did anybody look away? Or did anybody look straight at your partner and answer the question? Yes? Okay. What did everybody else do? Nothing? Yeah? Okay, closed his eyes. Okay. Did anybody look up at the ceiling? Or look off to the wall, look off into the distance? Okay, so why would you do that? We just talked about covert versus overt attention. You're having a conversation with someone. Why would you intentionally look away from them? Justin?
Get rid of distractions. So like I had to visualize my apartment. So I shut my eyes so that I'm not receiving all the other stimuli.
Right, exactly. Yeah. So this is one strategy that we use to avoid. Yeah, you guys can move back. We're done with the demo. This is one strategy that we use to avoid distraction. Is we avoid distracting stimuli. So I put on headphones to avoid auditory distraction. If you're having a conversation, you need to remember some bit of information. You look away from people's faces. Why look away from faces? Well, faces are socially important, right? We get loads of information from other people's faces, from their facial expressions, etc., etc. It's hard to ignore faces, and so if you're looking at them, so we look away in order to focus our attention on this internal representation that we have of your house and how many windows you have. All right, so that's one strategy, is to avoid distracting stimuli. Another strategy is to habituate. So with continued exposure to a stimulus, you're not getting any new information from static stimuli, for example, so from stimuli that don't change. So it pays to pay attention to them initially, get the information that you need, but then if nothing ever changes, then don't pay attention to it. So it's like the cooking example, right? So you get used to the smells of your apartment. So at first, that's new information, right? So if it smells like chocolate chip cookies, that's great. But after a while, you sort of get used to the smell of chocolate chip cookies. Would that it were as good smelling as chocolate chip cookies, right? So in the visual domain, you want to look at this painting initially. There's lots of information. It's really busy. It's a complex stimulus. But after a while, you've got all the information that you need from it. In the auditory domain, there's a new stimulus in here. Does everybody hear that? Whatever that is, that's new. And if it just stayed at this pitch, that would be fine. But it seems to be warbling between this and other pitches. Also, the sound of the fan in the projector. It's been going this whole time, but how many of you have ignored it until I just mentioned the fan and the projector? Right, yeah. So as soon as it turns on, you cue into that. You hear, oh, the projector's on. But after a while, it just sort of fades into the background. So this happens across all sorts of sensory domains. So the feel of the chair on your back. How many of you had ignored that until I mentioned it? So all sorts of stuff that we just get used to it, and so we don't attend to it anymore because you're not getting any new information from it. So all of this stuff is fairly simple, right? So the sound of the fan, the constant pressure of the chair against your back, all of that stuff doesn't change, but it's a fairly simple stimulus. This shows us an example of something that's complex, so visually complex, but again doesn't change, and so you habituate to it fairly rapidly. Let me show you an example of something that's simple but very difficult to habituate to. It makes me smile every time I say it. And you can tell from the date that I've been showing this video for a long time. And if you've been in my other classes, you've seen this video before. But I can't look away. I've got to watch him every time. Why is that?
Doing something because
how does he do that? Right, yeah. And if you see him walking along in his, white tennis shoes and sort of dorky sweatshirt, you think, oh, this kid's not going to be any good. But then he starts doing that, and it's like, wow, how do you do that? Right? And it's always something new, right? So as soon as you think, oh, that's kind of cool, then he does something completely different, and you think, oh, that's amazing. Ooh, I've got an idea for a new video that I'm going to show. I saw something over the weekend where there's a guy on a unicycle and a guy on a bicycle, and they're riding around a trampoline sunk into a stage, and they do some amazing stuff with a bicycle and a tricycle, or bicycle, a unicycle, and a trampoline. So you can Google it, and you'll probably get the same video. It's amazing, but it's like 14 minutes long. So at any rate, where was I going with that? Oh, yeah. So simple stimulus, just a single guy on the stage, but it's very, very difficult to habituate to it because it's constantly changing. So if you want to allocate your attention someplace else, then you need to habituate to static stimuli. And if it's constantly changing, so in the example in the library where, if it's a say you're in someplace busy, name someplace busy with lots of conversation. In the Wilkinson. Or yeah, some places in the library. So someplace loud, say you're in an airport, for example. Lots of stuff going on, but it's sort of a constant roar. You can tune that out fairly easily, right? So if it's a constant stimulus, but if it's that one person whispering and you can't quite hear what they're saying, but you can almost hear what they're saying, that's going to change, right? So that's going to vary, and that's going to draw your attention more than the roar of the crowd, right? So that's the first two strategies. One is to avoid distracting stimuli. Don't look at faces if you need to ignore them. Two is to habituate. It's easier with constant stimuli than with other stimuli. Three is to omit some stuff but ignore others. So if you've seen this video before, don't give it away. What is this video? Oh, I think the instructions are in the video.
This is an awareness test. How many passes does the team in white make?
All right, so let's count out loud. 1, 2. All right, the answer?
The answer is 13. But did you see the moonwalking bear?
All right, guy in a bear suit walks in. How many of you missed the moonwalking bear the first time? All right, nice, good. All right, so this is part of an ad campaign in London to try and get people to watch for cyclists, that it's easy to miss stuff that you're not paying attention to. So if you're focusing on cars and maybe even pedestrians or traffic lights or something like that, if that's the stuff you're paying attention to, then you're going to ignore the guy on the bike, or you're going to ignore the moonwalking bear, or stuff like that. If you're focusing on, in this case, what were you focusing on? Passes of the white team. So the team in white. So what does that mean? Ignore the team in black, right? So if the moonwalking bear was a polar bear in a white suit instead of a black suit, do you think you would have caught it? Yes, because how are you selecting what to pay attention to? Color, right. So you're defining it on this one visual stimulus, this one feature, and so you're ignoring the other feature in the scene, which is the team in black, or anything moving in black. So you miss the moonwalking bear. All right, so this brings up an interesting question. So we can focus our attention based on physical stimuli, physical characteristics. So the team in white, ignore the team in black. But usually we don't talk about attention like that. Usually we talk about attention as being selective for space. So which is it? Is it that attention is selective for space, that you're selecting your attention on a certain location? So, your conversation partner's face, or the television behind your conversation partner's face if you're doing covert attention. So is it for that location? Is it for objects? And And then what is the result of attending to a specific location? What happens both neurally and cognitively for the stimulus that's in that location? So some seminal work on attention comes from the Posner Lab and Posner's cueing paradigm. So this is a pretty clever experiment. So what they do is it's a stimulus detection task. So there's going to be a light flashing in one of two locations, and your job is to press a button when you detect the light in that location. It's a fairly easy task, right? So the dependent measure is how fast can you press the button, and subjects are encouraged to go as fast as they can without having too many false alarms. So don't press the button if the light isn't there, but when the light is there, press it as quickly as you can, right? So in order to help you, we're going to give you a cue. Either an arrow pointing to the location, or in some cases the cue is a symbol. So if the light in the middle is green, then it means it's going to come up on the left. If the light in the middle is red, then it's going to come up on the right. So the cue can be either spatial or symbolic. And the cue can either help you or not. So we don't tell the subjects this, but the cue is either going to be correct or it's not going to be correct. Subjects figure it out pretty quickly, so you might as well tell them. So don't always trust the cue. Sometimes it'll help you, sometimes maybe not. So the cue can be valid, meaning that it's going to point to the right location, or it can be invalid. So if it points to the left, and then the light is going to come up on the right. So that's an invalid cue. So it turns out, as I've noted here, that reaction times are shorter for valid cues. So you're focusing your attention in the middle of the screen, and you're told to keep your eyes fixated here, so it's covert shifts of attention. So you're focusing your attention, the cue comes up, it's going to be on that side. What do you do with your attention? You shift it to that location, so to the anticipated location. And so when the cue comes up, what do? Press the button, hopefully, and you press the button faster if your attention's already there. If you don't know, if there's no cue, so you're fixating here, stimulus comes up, what do you have to do in order to press the button? First, you have to move your attention to that location, then you have to push the button. And especially if you're focusing in the wrong location, then you've got to shift your attention farther and then push a button. And it turns out that your response times take a really big hit if you're focusing in the wrong place. So this is a no cue trial. So you're fixating on the asterisk. Probe comes up. You press the response key. If we cue your attention to that location, so in this case there's a red square that comes up around the target, and then there's a delay. You maintain your attention here, maintain your attention. Cue comes up, you hit the response key. You're fast. If you have an invalid trial, so this is a symbolic. So red is supposed to mean cue comes up on the right, cue comes up on the left. Instead, you get a hit to your reaction times. This is just some evidence that shows that the symbolic cue is not as good as the peripheral cue. So the peripheral cue is the spatial cue. So I cue your attention by flashing, a light over here, or I highlight this section over here. You're faster at moving your attention there. Why would that be the case? Why would it take you longer with a symbolic cue than with a peripheral cue?
You have to process which direction that cue is signaling.
Right, so there's an extra step involved there, right? So, all right, it's red. What does red mean? Red means right. Okay, so move over to the right. With the peripheral cue, is there any processing? No, it's just, that's the location, right? So you can skip that middle step, and so it's consequently about 100 milliseconds faster. So, in response to these data, so the data are that reaction times are faster if I've cued you to that location than if I haven't. Posner comes up with this metaphor for attention as a spotlight. So what's going on is when you're fixating, the spotlight is straight ahead, but when I cue you over here to your right, then you shift the spotlight over to that location, so when the stimulus comes up, you process it faster. So the spotlight of attention just allows you to process stimuli faster, more accurately. So when you move the beam over a location, it enhances the processing of stimuli in that location. Now, is there any evidence for this? Well, yes. I've just shown you behavioral evidence that's consistent with this. What about brain evidence? Does it turn out that there are brain regions that are involved in this in shifting your attention? Yes, it turns out that there are. So there are sort of 3 steps involved here, right? So you say you're fixating straight ahead. What's the first thing you have to do in order to shift that attention? Yes. Is that up here?
Yes, it is.
So yeah, so disengage, move, and engage. So if you damage posterior parietal cortex, it turns out you have difficulty disengaging your attention. Actually, yeah. So your attention gets engaged by basically whatever is in the environment. So you're not directing the disengagement. So what does that mean in terms of the Posner cueing paradigm? Well, if you can't disengage, valid trials are okay because you can engage your attention over to the location that you need it to. But on invalid trials, what's going to happen? So you've engaged to the wrong side of space. You need to disengage and move over to here. And it turns out that you're really bad for disengaging in the contralateral side of space. So if you have damage to the right posterior parietal cortex, then you have difficulty disengaging from the left side and shifting your attention over to the right side, and so you really take a hit.
So, if like I got in an accident and got this, would I show similar signs to the autistic people who, like, once you start a task, you need to complete it before you move on, like with puzzles and stuff, or is it?
No, it's more visual spatial attention and less sort of task-based attention. So yeah, these folks don't look a lot like autistic folks. You can damage the move. So this would be a case of the superior colliculus. So if you have superior collicular damage, then valid trials, you're very slow to show an advantage, but you do show an advantage to having a cue. Invalid trials, you're slow, but it's not a special problem. At short delays, you don't use the cue at all, because if I give you the cue, what do you have to do? Move your attention over to that location that was cued. But if you're having difficulty moving your attention, then if I give you the cue and then the target right away, you haven't moved your attention to the wrong place. You can move it to the right place, and so you don't see as great a hit as typical. I'm trying to get away from saying normal controls, as typical individuals who don't have brain damage. And then if your engage is damaged, so this is the thalamus is responsible for this, you don't seem to use the cues very much. So valid cues, invalid cues don't really matter that much. You're easily distracted by irrelevant stimuli because you're not engaging your attention on any individual thing. So if you have irrelevant cues that are sort of flashing up all over the place, then you're really going to take a hit because you can't filter that out. You're not engaging on the thing that's most important. So the beam metaphor does work in some sense. So the behavioral evidence indicates that yes, attention seems to work like a spotlight. Yes, the brain data indicates that there's separable processes for disengage, move, and engage. But some of the predictions made by the spotlight metaphor don't actually pan out. So, for example, if you need to move your attention between 2 distant locations versus 2 adjacent locations, it doesn't take any more time. So if it was like a spotlight, the farther you had to move it, the longer it should take. But it turns out that's not the case. Also, if you have intervening stimuli, so if you have a bunch of stuff in the middle and you need to move your attention over all of that stuff in order to get to the location that you need to, that doesn't slow you down versus having just blank space. If you were attending to all the locations in the middle, that should actually slow you down because you should have to process everything in the middle, but it turns out you don't. So it doesn't seem like you're moving the spotlight. It seems like you're sort of teleporting the spotlight. You shut it off over here and instantly it comes up over here. Also, the beam implies attention selects space. And we've already seen an example where that's not necessarily the case. So let me show you another one. So I'm going to show you a bunch of words. There are actually 2 words on each slide, one written in red, one written in another color. I want you to ignore the words that are not in red and remember the words in red for a later memory test. Okay? Make sense? So I'm going to show them hopefully one every 2 seconds or so. Okay, which one did you see? Crime, crown, or country? Head, hold, or hate? Head? Slight, sold, or skin? Slight? Maybe? You're less sure. Sold? Skin? Any votes for any of the others? How about these? Peace, people, paper? Paper? Maybe? All right, so you were very confident on the red one. So it was crown for the first one, head, paper was the gray one, and slight, dance, and part. All right, so slight and paper were the ones that you were to ignore. But if attention was a spotlight, right, and you're focusing your attention on this location in space, does it matter if it was written in red or gray? You should process everything that's in that location in space, right? So does it matter whether the team is wearing, the players are wearing white or black? If you're focusing on that location in space, you should see everything, right? But it turns out that you can select based on things other than location. So in this case, we're selecting based on the color red. Similarly, with the moonwalking bear video, you're focusing on the team in white and not the team in black or anything in black, including moonwalking bears. So the point is that you can selectively attend to just one word based on the color, and you can ignore everything else that's in the same location. So the spotlight metaphor doesn't necessarily work for this instance. So the implication is that when you switch, you're switching not to a location in space, but to a different feature of the environment.
Well, and I just like you move around when you talk, but I don't really notice because I'm just paying attention to what you're saying, you know. And so I think that's the same.
So I should just stay in one little place. It doesn't matter.
You know, if it was more like a spotlight, I would be noticing you and the India poster and the behind you. But like you're moving around, and I'm not really paying attention to everything.
Right. Okay. Yeah. Yeah. So it doesn't actually help us all that much usually to pay attention to everything in that location. It helps us more to pay attention to that object, right? To that individual, for example. Okay, so next time we'll pick up with visual search and figuring out, okay, sometimes you're not attending to what you need to. How do you select something that you don't know in advance where it is?